Okay, this video is on 3.2. It is an additional supplement that I made as an activity. So it's in addition to the notes that you already have, but I wanted to just go through a little more. 3.2A is what I called it in the activity. So this one is on future value of annuities. So a lot of times people can't just put one big lump sum in the bank, but you can save up every month or so. You know, it could even be every year you put some money in, and we'll see at the end how a woman did that and made, you know, a good amount there. So here we have Annuity Formula. So this should be familiar from your lessons. P sub N is the end amount that you end up with. D is deposits. So it's whatever you're putting in every month or so, whatever the period is. K is the number of compounding periods in 1 year. R is the same rate as a decimal. N is time in years. So it's a little different. We used to use T in the other like simple interest, but here we're using N, and K again is our number of compounding periods in 1 year. So be careful when you do this, when you type into a calculator, make sure you use parentheses around that, or just do it out ahead or do it in your head. And mathematically speaking, I just want to write an equivalency here. So P sub N can also just be written as D times all of this stuff in parentheses, 1 plus RK to the NK minus 1, all divided by R over K. In this use of the parentheses here is helpful when you're solving for D, like in one of the problems. That's just going to be easier to crunch the numbers that way. I would love to walk you through the calculator stuff again. I did do that on your other videos with a document camera. This one I don't have a little calculator that's the same type to pull up, but I will just tell you kind of what to press so that if you're using the multi-view or something similar, you'll know like where to put parentheses. Although you can just type in things like literally like you could a computer, I wouldn't suggest that because it's really easy to mess up like one parenthesis and then it just throws everything off. So make sure, you know, you read through all these notes here. I'm going to go over one more thing here. Things to know. So we have annuities assume that you put money in the account on a regular schedule every month, year, quarter, etc., and let it sit there earning interest. So it's also getting compounded every time you put it in. So the number of compounding has to match the number of deposits. Compound interest is just a step down from that. It's just you put a lump sum and then let it sit there earning interest. The bank is active compounding also. Compound interest again is one deposit. Annuities are many deposits. So you should be able to start to recognize that. Simple interest, on the other hand, will specifically say simple interest right in the problem, or it will just say nothing. It won't say it's compounded, or it won't say like you have any deposits that you're making other than the first one. So one thing you might find helpful is to think about the definition of what is the future value of an annuity. You're saving up for something. So that's that form of the formula where we're looking at the end amount, what we're going to have. We don't have the thing now and we're paying it off. Like the loans, 3.2B, that's what that looks like mortgages and credit cards and car loans. That's all things you have now, or even if you have money in the bank and you're withdrawing it out, that is called a present value annuity, and it's a different formula. So you have to really make sure that you're using the right one. So the other one has a negative in the exponent. You've probably already seen that in your lessons. But just really start to think about when you're doing these, what makes them all kind of have the same pattern, and when you'll use them, and how can I differentiate these things, because in the next week we're gonna mix things together. So I encourage you just to jot some notes down in your own words. That's just a space for you to use. I'm going to actually put a little flowchart here, not a flowchart, but a timeline. After history and math, you guys are all really into timelines, right? So here is my timeline. I'm just going to write it right above this problem. And this problem references having a 3-year time span. I'm going to put my 3 years in there. Here's year 1, year 2, year 3. Okay, and it says you decide to deposit $1,000 every 6 months. So what I'm doing here is at 6 months, and I put it in at the end of the 6 months. So I put in $1,000 right under here. I also put one in here at the year mark, $1,000. A year and a half, I'm putting in $1,000. 2 years, put in another $1,000. 2.5 $1,000, and 3 years, I put $1,000 in. So start thinking about, like, I actually put in $6,000 altogether. So I'm taking my deposit, which is D, so I'm going to track that down over here. D equals 1,000. Okay, and I'm putting it in every 6 months. So that is 1, 2, 3, 4, 5, 6 times I do that. Okay, so that's my K is 6. And then I do that over 3 years. So let's read the entire problem here. If you decide to make 6 deposits when at the end of each interest payment period, that's just called an ordinary annuity, over 3 years, how much money will be in the account? So that's another clue. That's future value with the piece of N formula. Will be in the account after the last deposit is made, and then how much interest has accrued over the 3 years. And that's a little trickier. First, we need to figure out the piece of N, what that comes out to be, how much we're going to have in the bank, and then we're going to subtract off how much we put in. So we know we have N equal to 3 because that's 3 years. So my total deposits that I put in, I'm going to track that right under here. Total deposits is going to equal the 1,000. So that's, I'm doing my D times my K times my N. So that would be 1,000. You could just do this in your head, but whoops, sorry, I made a mistake here. K is not 6. K is 2 for twice a year. I already had multiplied the K and the N when I was thinking about that. But K is the number of times compounded, number of compounding in 1 year. So sorry about that. So go ahead and fix that to be a 2. And then we would have 1,000 times 2 times 3. And that's where I get my 6,000. So I put in 6,000 total, okay? And if I figure out how much I end up with in the bank, which is hopefully going to be, should be more than 6,000, right? If you end up with an answer that's less than that, you know something went wrong. And then I'm going to subtract the 6,000 off my end amount in the bank. So let's plug into that formula that we had above. I'm going to rewrite that up here so it's handy for us. Okay, so I have P sub N right up here. Formula for that equals D times 1 plus R over K to the NK minus all minus 1. Make sure that's not part of the exponent. I'll write that a little lower. Minus 1. And then we have all divided by R over K. Now, R over K represents our periodic rate. So that is going to be every 6 months. It's going to be, how much was our percent? 6% compounded semi-annually. So our R is 0.06. Okay, so if we write that up here, that would be 0.06 divided by 2, which would be 0.03 for each of these periods. That's my periodic rate. So you might sometimes see it written like that too. And together in a year, they would add up to 0.06. So now we're going to plug into this formula up here. We're going to find P sub n equals D, which is 1,000, times quantity 1 plus 0.06 over 2, or you could just put the 0.03 in there, times parentheses, our N is 3, our K is 2, so 3 times 2, make sure you use parentheses if you're typing in a calculator, minus 1, and then I also want to have parentheses around that, all divided by 0.06 over 2. And then you're going to crunch the numbers. And if I were typing this in a calculator, even though you can't see it, I'll tell you what I'm doing. I'm going to start here with my my fraction, because if it doesn't terminate, I want to try to keep everything in my calculator. So I'm going to go 0.06 divided by 2. This one does terminate, so it's fine, but then plus 1. Don't forget to do that. You'll get a cockamamie answer if you'll notice. So I end up with 1.03. Then I want to hit the exponent key. It looks like a little caret on a computer, a little triangle without a bottom. So it'll say ANS, and then you have a little box to put parentheses 3 times 2. Again, you can do this in your head, of course, but I want you to know how to type it in a calculator for bigger numbers or things that you wouldn't really want to write down or you're not able to do in your head. So there's a little blinking arrow if you're using the Multiview or the Multiview Pro. So just go up to that little kind of oval on the upper right and arrow to the right to get that prompt down, and then hit enter. And I get 1.19405, so on and so forth. And then I'm going to subtract the 1. So I'm just right here, I'm subtracting 1, okay? And I hit enter, and I end up with 0.194, multiply by 1,000, and I get, I'll write that in between step here, P sub n equals 194.0522 dot dot dot. So I write the dot dot dots just to show that in between step. This is a good idea for you to do on a quiz or any kind of homework, so you know, like, you're not rounding, but I can see where you're at in case something went wrong. And then the 0.06 over 2 is divided by 0.03. Don't forget to do that. And then your answer comes out to be $6,468.41. So I haven't answered the question in full yet because it asks how much money will be in the account after the last deposit is made, but it also asks how much interest has accrued over the 3 years. So my first answer is there will be $6,468.41 in the account. And I have accrued or gotten cumulative interest. I'm just going to subtract what I put in. 6,468.41 minus the 6,000 I put in gives me $468.41 in total cumulative interest. The thing you want to be careful of here is not to just say, okay, I earned the interest, I'm just going to do like 0.06 times 1,000, that's the interest. No, that would be simple interest. So we want to be real careful and real specific. Okay, so that's your answers for problem number 1. I can write out a little formula here for you if you want. So the formula I used for cumulative interest, it's right here in the pink, interest equals P sub n minus, you can use parentheses or not, but the DKN. Okay, so just so you know where I got all those numbers, that's the little formula there for you. And you can use that for number 2 as well. Number 2 is very similar, so that one you can do on your own, and then you can check against mine. I'll fill in all the blanks. I know when I was doing this with the hybrid, some people thought maybe they should multiply that 2,000 by the 20 and put that in for D, but just so you know, so you get started on the right track, this 2,000 is deposited, so that actually is D. Okay, so D is 2,000, and then the 20 represents my N. I treat those separately, and I have to also look at 8.5% compounded annually, so my K is going to be 1. I'm depositing each year, so that matches. That's 1. My interest, R, is my annual interest, 0.085. Always move 2 places left. Okay, so you should be able to plug all that info into the formula that is up here. It's also on your paper if you have that, but just in case you don't, you might want to rewrite that somewhere where it's easily seen if you're just writing this in a notebook, but you probably can jot it down right here. And then plug everything in and crunch the numbers and make sure as you're working your calculator that you're matching up to mine. Even in problem 1, I'd go through and make sure you're really comfortable with using your calculator. And if you have any questions or it's not coming out right, you can take a little video of yourself, maybe what you're typing in, and send it to me. Send me an email and I can look at it, and I can say, usually in a class, like I'll see, oh yeah, that's why you hit this instead of that, and it just clears up a lot of frustration really quickly. So certainly feel free to do that. Okay, I'm going to finish this one off with problem 2, and then I'll make a separate video. I don't like them to get too long because then they take a while to upload. So problem 2 is plug in everything here. We've got a deposit of $2,000, and my rate is 0.085. My K is just 1, so I really didn't need to put it in there, but I just want you to see, you know, tracking where it goes. So I would just crunch these numbers. I can really just go 1.085, raise it to the 20, subtract 1, then multiply by 2,000. What you don't want to do is distribute here. You cannot distribute when there's an exponent involved. You would have to follow your order of operations, okay? And then I'm going to divide by all this numerator by the 0.085, and that's what I did over here. and I get $96,754.03 is the value of the annuity. Then total cumulative interest, I have to take that piece of N, so my future value, minus what I put in. So I put in $2,000 every year for 20 years. So that's the 40,000, and subtract that, I get $56,754.03 is earned in interest. That's a pretty great deal. So that's the answer for this problem 2. And then it has 2 parts though. So make sure you answer both parts clearly, or else it's just you won't get the full points on a quiz. So you want to make sure you have all that down. So I will do number 3 in a separate video, but if you want to start trying it, one thing to think about is this time you're solving for different variables, same formula, but watch what you're given. Be careful of what you're given and put things in the right spot. So have a great day, and I will take up with this second half shortly.